How are you, everybody who is watching this fantastic video? I would like to take this opportunity to welcome you, a very important student or learner or hobbyist or technician or engineer who love these contents. My name is Olenjolain. I am from a beautiful country that's called Tanzania, and I would like again to take this opportunity to welcome all the local students that I have and online students who are following this content. So one thing which I want to tell you that I would like to ask you to concentrate and keep in touch with what we are going to cover today. So these contents are very important for beginners, students who would like it to be electronics engineers or electronics technician or electrical engineers or electrical technician or telecommunication engineer or telecommunication technicians or computer engineer or computer technicians, biomedical engineers, biomedical technicians, or even hobbyists who love these things that have been revolving and changing the world. So these contents I have prepared it specifically to help ordinary diploma students who have graduated the form for education and then they wish to go for the technical schools or for the technical college in order for them to acquire different skills and special competence based. But these contents also can help even our first year or second year or third year engineering students in electrical field, whether telecommunication engineering or electronics engineering. For instance, I have some local students who are taking ordinary diploma in electronics and telecommunication engineering. And in order to appreciate and acknowledge their presence, let me introduce them and let me just welcome them and greet them in order to present even for you online community. Good morning. How are you, class? Class, how are you? Okay, so these contents for the Tanzanians can help NTA level 4 students, NTA level 5 students, NTA level 6 students, NTA level 7 students, NTA level 8 students, because these are the fundamental concepts that we have to teach students who love electronics. But it's not only for students, even for the professionals who would like to get some updates of the previous or fundamental concepts, or they would like just to understand the concept. So if that's the case, then I think that at least now you have analyzed yourself that you are among of the targeted community or targeted learners, or you are not among those targeted learners that I have mentioned. But one thing which I want to tell you that this is the modules that we've been learning in one of the institutions. Very interesting modules. So we have recorded workshop 1, workshop 2. So today, welcome for the workshop 3. And then in case that you've missed workshop 1 and workshop 2, you can go into our official YouTube channel in order to access those contents before you come for the next workshop, workshop 3. So you have to stay tuned. One thing which I want to ask you, this is serious program. Be serious. Take your exercise book, take your pencil, take your ruler, take your pen, and then make sure that you have a fresh mind to receive a new information. So if that's the case, let us go to the business. So in this workshop 3, we are going to learn about electronic schematic symbols of electrical and the electronics components or devices. So before we go for the workshop 3, let me do a quick review of workshop 2. So the quick review of workshop 2. So in workshop 2, I have told you that the electronic schematic symbol basically of 3 or of 2 semiconductor devices. The first one, we have learned different schematic symbols of diodes, and then also we have learned different schematic symbols of transistors. So this is all about what we covered in workshop number 2, right? To go into a little bit details, we learned the schematic symbols. We say we have 2 categories of diode. We learned the schematic symbol of general purpose diode, and we say that purpose diode, and you remember, and this is the fundamental, this is the symbol for the schematic circuit diagram, so general purpose diode. But also I have mentioned the second categories of diodes, which is special purpose diode. So in special purpose diode, I have told the schematic symbol of what? The schematic symbol of the light emitting diode, schematic symbol of the photodiode, the schematic symbol photodiode, the schematic symbol of what? Of Schottky diode, Schottky diode, the schematic symbol of what? The schematic symbol And then I left the homework for students to do, to go and find the schematic symbol of the tunnel diode, right? But also I have taught you the schematic symbol of Zener diode. Then I gave you a task to go and find some other two special purpose diode. So let me do assessment for the local students. Did you manage to find the other two special purpose diode? The answer is either yes or no. No. And others? Did you manage to find? Mohammed? No. Mohammed Hussein. Filippo? No. Davis? No. Hashim? No. Allen? You found? Another special diode is called what? Rectifier diode. Okay, rectifier diode. That's the combinations of the general purpose diode. And the second one? Pardon? Bridge diode. Pardon? Pin. Pin diode. Pin diode. The other one? You just said the two. Prosper? Did you find some other special diode? One of them is what? Varak or Varat? Can you come and write? Can you mention the spelling? V-A-R-A-C-T. Then O-I. O-R. Varactor diode. Clap your hand for him. This is true. This is one of the special diode. Say Varactor diode. Clap your hand for him. Okay, so Varactor. So did you find the schematic symbol of tunnel diode? Not yet, Okay, so then those are the schematic symbols. So 1, 2, 3, 4. The other one is what? 4. Okay, 4. And this one 5. So tunnel 6. Varactor now you have what? 7. But there are different special purpose diode. Then I taught you the schematic symbol of bipolar junction transistor. And then we say that NPN, bipolar junction transistor. And also we learned the schematic symbol of 40 of PNP, bipolar junction transistor. Then, so it means we learned two schematic symbols for NP, for the bipolar junction transistor, right? But we define also what the means of bipolar junction transistor. Because I have been introducing. But then we learned about unipolar junction transistor, right? In other words, we call it a field effect transistor. Okay? So in this case, we say that field effect transistor are categorized into two groups. So you have what? Junction field effect transistor, and also you have metal oxide semiconductor, semiconductor field effect transistor, which call them what? MOSFET, right? And then, so we learned the schematic. So we did not learn the schematic symbol until we categorize the junction field effect transistor. We say that we have two types of junction field transistor. The first one is called N-channel JFET. N-channel JFET. So I told you the schematic symbol of this one, right? Then the second one is called P-channel junction field effect transistor. We learned also the schematic symbol of this one. We did not learn the schematic symbol of this one because there is no special symbol for this, and there's no special symbol for unipolar junction transistor. So until you classify them and you learn the year types, that's the moments when you also learn the schematic symbols. Are we together? Are we together, class? Okay, in case you have a question for the online community, don't hesitate to ask in the chat, or don't hesitate to ask in the comment section. So, for the MOSFET, how many types of MOSFET do we have? We have two modes of MOSFET. Depletion mode, MOSFET. Depletion mode, MOSFET. And also you have enhancement mode, MOSFET. Enhancement mode, what? MOSFET. So in depletion mode MOSFET, we have two types. We have N channel and also we have P channel. Enhancement mode MOSFET, also you have two types. We have what, Filippo? N channel enhancement mode MOSFET and what? P channel enhancement mode what? MOSFET. So this is the schematic symbol of what? N channel enhancement mode what? MOSFET. So we learned all of these schematic symbols. Okay, class? So today, let us continue with our concepts of schematic symbol. In case you have any question about workshop 2, you should not worry. For the local students, you'll have that video at your hands within a short time, so you should not worry. Okay, so then we say that, so think a little bit about what we have been learning yesterday before we cover the new content today. Okay, so I think that you had a good opportunity to remember what you have learned yesterday. So today, let us learn the schematic. I don't know the numberings, whether this is number what, but simply say, let us learn the schematic symbol. The schematic symbol of operational amplifier. So operational amplifier. So the schematic symbol for operational amplifier, simply we said that the schematic symbol of 40 of op-amp. Class A operational amplifier. So this is an analog integrated circuit. It's still the semiconductor. It consists of a number of the transistors, but when the transistor has been biased to operate as what? As an amplifier. Right? So it's a kind of the integrated circuits, but the good thing that the operational amplifier op-amp has its own schematic symbol. However, that will show or will teach you about the schematic symbol of the integrated circuits in the next workshop. So because our main focus is the schematic symbol, we say that in electronics engineering, there are two types of operational amplifier of op-amps, and these two types, we name them. The first one, we name it as what? As non-inverting operational amplifier. Non-inverting operational. Class A, non-inverting operational amplifier. Again, say non-inverting operational amplifier. The second one, we call it inverting operational amplifier. So we have non-inverting operational amplifier or non-inverting op-amp, and the inverting operational amplifier or inverting op-amp. So straightforward, the schematic symbol of non-inverting operational amplifier So these two types of operational amplifier, they have the same schematic symbol. So the schematic symbol of inverting, the difference is just the connection. Inverting and the non-inverting op amp is this one. So we have a triangle, then negative, positive. And then we have the power pin, but also used to have, no, the output pin. So this is input pin, and this is positive voltage pin, and this is negative voltage pin. So this one we call it, usually call it positive supply voltage, and this one we call it negative supply voltage, and this one we call it output pin, and this one we call it non-inverting terminal, and this one we call it inverting terminal. So inverting terminal, and this one called non-inverting terminal, and this is inverting terminal. This is output terminal or output pin. Listen. So this is figure what? The number figure 20. Yeah? Yeah? 22. Okay. So this is the schematic symbol or 40 of op amp. So listen, most standard operational amplifier have 8 pins. Listen, stop drawing, stop writing. Most standard operational amplifier or most standard inverting, or most standard op amps, whether it is inverting or non-inverting, have 8 pins. So the minimum number of pins for any operational amplifier is 8. And all the operational amplifiers are built-in in the form of integrated circuits. In the form of integrated circuit. So, but those 8 pins, when you analyze this schematic symbol, we don't represent all the 8 pins of the operational amplifier. We have just represented only 5 pins of the operational amplifier. So there are 3 pins which are not shown here. Why? Because in most of the standard op amps, integrated, in most of the operational amplifier integrated circuits, you find more than 1 op amp. So there are 3 operational, there are 2. The minimum number for the op amp integrated circuits of the 8 pins, it consists of 2 op amps, right? But those 2 op amps will be sharing the same power supply. So I don't want to go into too much details about operational amplifier because it's a broad subject, right? To simplify the concept, the physical appearance of the operational amplifier or of the op amp, it consists of 80 pins, right? So among those 8 pins, we just represent the operational amplifier by using 5 terminals or 5 pins. Pin number 1, or this is the first pin, the second pin, the third pin, the fourth pin, the 15th pin, right? So I told you that the operational amplifier integrated circuits of the 8 pins, it has how many op amp? 2 op amp. So where are the 3? So the 2 op amp will be sharing the power source because this is positive power supply, or this is the pin where you connected the positive voltage, positive DC voltage. And this is the negative where you connect the negative from the negative terminal of the DC source. Are we together? So it means the 2 operational amplifier within the same integrated circuit will be sharing power. So this pin is common, right? It means op amp 1 is connected to this pin and op amp 2 is connected to this pin. Op amp 1 is connected to this pin and op amp 2 is connected to this pin. Why? As just we used to draw the power supply, the block of power supply unit, and the block of power supply unit used to power other parts. Are we together? Are we together? So the op-amp receives power from what? Positive voltage pins and negative voltage what? Pin. Right? So if 2 pins are for power, 8 minus 2, remain what? 6 pin. Right? So the 6 pin, the 3 pins will be for op-amp number 1. And the other 3 pins will be for the op-amp number 2. Makes total how many pins? 8 pins. So when we learn about the schematic symbol of the particular electronics or electrical components, we have to learn the schematic symbol of representing 1. Okay? Okay, class? Okay, class? So I'm trying to relate the schematic symbol and the physical appearance of the component. Okay? Okay? So these 2 terminals for power supply. And these 2 terminals for the input to the op-amp. And this single terminal is for the output from the op-amp. Are we together, class? Are we together? And this negative sign and positive sign have no any meanings of power source. The negative sign is just a representation of non-inverting terminal. And the positive sign is just a representation of inverting terminal. So, can I repeat? The power supply is supplied to the operation amplifier by using positive voltage pins and negative voltage pins. Right? Right? This symbol of negative and symbol of positive is just to differentiate the input terminals of the operational amplifier. So the terminal which has a negative sign is non-inverting terminal. And this one with positive sign is inverting terminal. That's all. Right? Is it interesting? So this is all about the heart of analog electronics. So when you master operation amplifier or you master transistor amplifier, then you are mastering the heart of analog electronic system. Okay? Okay? Fine. Again, in electronics and electrical, we use sometimes some other electrical or electronics components. This we call them mechanical, yes, electromechanical components. So now let me teach about the schematic symbol. The schematic symbol of what? The schematic symbol of crystal. The schematic symbol of crystal. Say schematic symbol of crystal. Say schematic symbol of crystal. Say crystal. Say crystal. So crystal, it's an oscillator. Crystal, so let me just see, because I know you're a beginner. The crystal is an oscillator. It's electromechanical components which has ability to produce vibration within the circuit. Right? So a crystal, actually that, it's receive electric signal and then produce waves. That's the function of the crystal oscillator. So a crystal oscillator simply, it's electromechanical components which needs electricity or receive electrical current and convert that electrical currents into waves, electrical waves. So it can be either sinusoidal, it can be either square wave, it can be either sawtooth, it can be either triangular, it can be either pulse. Are we together? Are we together? So in all the microcontrollers that I have taught you when I've been teaching the concepts of 40 general block diagrams of 40 electronic system, right? We had a control unit, and I told you in most cases we can have integrated circuits or logical IC, integrated circuits, or microcontroller or microprocessor. So whether the microprocessor or the microcontroller, it cannot work without a crystal oscillator. A crystal oscillator. And the crystal oscillator is the one that is producing waves or electrical signals, vibrating signals, that we call them, or we measure them in terms of frequency. So the crystal oscillator, you can find a crystal oscillator of 8 kilohertz or crystal oscillator of 8 megahertz or Christ oscillator of 16 megahertz, Christ oscillator of 32 megahertz, Christ oscillator of 64 megahertz. So the concept as a beginner, it means a Christ oscillator or oscillator is the electronics device or is electromechanical device which producing what? Oscillations or waves. And they're electrical waves. They are not electromagnetic waves. Are we together? Eh? Yes. So simply we say that the schematic symbol of Christ oscillator, we say that a Christ oscillator, just to give you a brief, is a electrical component that uses electric energy to produce waves, to produce electrical waves in particular shape and a frequency. Particular shape and frequency. So you say that in electronics, engineering, or in embedded electronics, in embedded electronics engineering, the crystal oscillator is used to produce clock signal to the microcontroller, the microcontrollers. But remember that this class is not about oscillators. This class is all about schematic symbol. So the schematic symbol, that's why I don't want to go, but I have to give you an idea. The schematic symbol of crystal oscillators, the schematic symbol of crystal oscillators, the schematic symbol of crystal oscillator is this one. So whenever you see any schematic symbol of this shape, so that the crystal oscillator, and then can be written in its own frequency. So you can find that this is terminal 1 and this is terminal 2. So this is figure what? Figure 23. The schematic symbol. Schematic symbol of 40 of crystal oscillator. So when you analyze the crystal oscillator, it has only 2 terminals. But also we have another electron. So we don't use the crystal oscillator itself. We need 2 ceramic capacitors. We call them parasitic capacitors. So when we combine or when we integrate the Christ oscillator with capacitors, then we have another electrical or electronics components that we call the resonator. Class A, Christ oscillator. Say Christ oscillator. Huh? So then we have also the schematic symbol of resonator. Schematic symbol of schematic symbol of resonator. The schematic symbol of resonator. So simply we say that a resonator, say resonator. Say resonator. Say resonator is the sub, or is the combination of crystal oscillator with two capacitors, ceramic capacitors. Ceramic capacitors connected in parallel. Connected in parallel. So when you have, so stop writing. So the schematic symbol of resonator, look here. The schematic symbol of resonator has three terminals. So you say that the resonator, for that case, the resonator has three terminals. Has how many terminals? Stop writing. The first two terminals are the two terminals of the Christ oscillator. Stop writing and stop drawing. So this is the first terminal. So this is the first terminal where we have what? Resonator. Where we have a Christ oscillator. And then we connect this Christ oscillator in parallel with two capacitors connected in parallel. And these are the ceramic capacitors. Remember that this is the introduction, and here we have the steady terminal. So this is capacitor 1, this is capacitor 2. And this so this is the Christ oscillator. This is ceramic capacitor connected in parallel. So this is terminal 1, this is terminal 2, and this is terminal 3. Are we together? So it's 3 terminals right now. And this terminal always we used to connect it to ground. So this is figure, so you write at the bottom, this is figure 24. The schematic symbol of what? Of a resonator. Schematic symbol of what? Resonator. Then let us go to the schematic symbols of headers Headers and the connectors. Schematic symbol of headers and connectors. Say schematic symbols of headers and connectors. Headers and connectors, these are very important. Listen, headers and connectors, when we go for the schematic, that the function of the crystal oscillator. So a crystal oscillator simply, it's electromechanical components which needs electricity or receive electrical current and convert that electrical currents into waves, electrical waves. So it can be either sinusoidal, it can be either square wave, it can be either sawtooth, it can be either triangular, it can be either pulse. Are we together? Are we together? So in all the microcontrollers that I have taught you when I've been teaching the concepts of general block diagrams of electronic system, right? We had a control unit, and I told you in most cases we can have integrated circuits or logical IC, integrated circuits, or microcontroller or microprocessor. So whether the microprocessor or the microcontroller, it cannot work without a crystal oscillator. A crystal oscillator. And the crystal oscillator is the one that is producing waves or electrical signals, vibrating signals, that we call them, or we measure them in terms of frequency. So the crystal oscillator, you can find a crystal oscillator of 8 kilohertz, or crystal oscillator of 8 megahertz, or crystal oscillator of 16 megahertz, crystal oscillator of 32 megahertz, crystal oscillator of 64 megahertz. So the concept as a beginner, it means a crystal oscillator or an oscillator is the electronics device or is electromechanical device which producing what? Oscillations or waves. And the electrical waves, they are not electromagnetic waves. Are we together? Eh? Yes. So simply we say that the schematic symbol of crystal oscillator, we say that a crystal oscillator, just to give you a brief, is a electrical component that uses electric energy to produce waves, to produce electrical waves in particular shape and the frequency. Particular shape and frequency. So you say that in electronics, engineering, or in embedded electronics, in embedded electronics engineering, the crystal oscillator is used to produce clock signal to the microcontroller, the microcontrollers. But remember that this class is not about oscillators. This class is all about schematic symbol. So the schematic symbol, that's why I don't want to go, but I have to give you an idea. The schematic symbol of Christos laters, the schematic symbol of Christos laters, the schematic symbol of Christos later is this one. So whenever you see any schematic symbol of this shape, so that the Christos later, and hence can be written in its own frequency. So you can find that this is terminal 1 and this is terminal 2. So this is figure what? Figure 23. The schematic symbol. Schematic symbol of 40 of Christos. Christos oscillator. So when you analyze the Christos oscillator, it has only 2 terminals. But also we have another electron. So we don't use the Christos oscillator itself. We need 2 ceramic capacitors. We call them parasitic or parasitic capacitors. So when we combine or when we integrate the Christos oscillator with capacitors, then we have another electrical or electronics components that we call the resonator. Class A, Christos oscillator. Say Christos oscillator. Huh? So then we have also the schematic symbol of resonator. Schematic symbol of schematic symbol of resonator. The schematic symbol of resonator. So simply we say that a resonator, say resonator. Say resonator. Say resonator is the sub, so or is the combination of Christos oscillator with 2 capacitors, ceramic capacitors. Ceramic capacitors connected in parallel. Connected in parallel. So when you have, so stop writing. So the schematic symbol of resonator, look here. The schematic symbol of resonator has 3 terminals. So you say that the resonator, for that case, the resonator has 3 terminals. Has how many terminals? Stop writing. The first 2 terminals are the 2 terminals of the Christos oscillator. Stop writing and stop drawing. So this is the first terminal. So this is the first terminal where we have what? Resonator. Where we have a Christos oscillator. And then we connect this Christos oscillator in parallel with 2 capacitors connected in parallel. And these are the ceramic capacitors. Remember that this is the introduction, and here we have the steady terminal. So this is capacitor 1, this is capacitor 2. And this so this is the Christos oscillator. This is ceramic capacitor connected in parallel. So this is terminal 1, this is terminal 2, and this is terminal 3. Are we together? So it's 3 terminals right now. And this terminal always we used to connect it to ground. So this is figure, so you write at the bottom, right at the bottom, this is figure 24. The schematic symbol of what? Of a resonator. Schematic symbol of what? Resonator. Then let us go to the schematic symbols of headers, and the connectors. Schematic symbol of headers and connectors. Say schematic symbols of headers and connectors. Headers and connectors, these are very important. Listen. Headers and connectors. When we go for the schematic circuit diagrams, I will show you all of these electronics components. Hold on. When you go for simulation, by using those simulation software, we have all the schematic symbols of all of these components, right? Yes, but later on also I will show you each component after the other one. How does it look like? Okay? So headers and connectors, these are the electrical, or we call this electronics components, which are providing the external connection. Listen, the external connection. For instance, this is the motherboard. This is your motherboard, or this is your PCB board. But then you want to connect the power. You want to connect the power. So when you want to connect the power, let's say from any external source, you will find that we have either connector or headers. Two of them, where that actually we use to connect. For instance, let us take a simple example, the USB or the power cable. Let's say the power cable of the computer. Do you know the adapter of the computer? So the adapter of the computer, always, the adapter itself, it has a male connector, right? And then the computer, it has a female power connector, right? So if you want to provide power to your computer, you have to connect them. So the point where the power cable is connected is the simple meaning that we have in electronics in case of the headers and connectors. For instance, this is your motherboard again. This is your motherboard within the waterproof box. Okay? So if you want to connect, let's say outside of this waterproof box, you wanted the LCD or the display to be out, to be seen by the use of that system, right? So in order to connect the pins of this LCD with the motherboards or with the PCB boards, then you need something, we call them jumpers. Okay, say jumpers. So the jumper, it's a one that which can take electric signal and do the external connection. So we use these headers and connectors in order to connect one part of the circuit with another part externally. Right? We have female headers or female connectors, and also we have male headers and male connectors. Class, are we together? Are we together? Just for today, know that in electronics we have headers and the connectors. How they look like, it is difficult for me to explain and just give you the imaginations because possibly you have never seen them. But in the next class, you will see them. Are we together? So he said that in electronics and the electrical engineering, when I say electronics engineering, means telecommunication engineering within it. In electrical engineering, there are two types of headers and the connectors. Headers, female header, male header. Connectors, T block. So it means the first one, we say that we have male headers. And also we have what? Female headers. Also we say that we have male what? Connectors. Then we have what? Female connectors. So we say that headers and connectors have different number of pins. So they are usually, these connectors and headers, they are used to send in the informations into the circuit or outside of the circuit. So we say that headers and connectors have different number of pins. Different number of pins. So the standard ones, most of the headers, we can find maybe the header of 1 pin, 2 pins, 3 pins, 16 pins, 20 pins. So it depends on your design. So the schematic symbol of headers. The schematic symbols of headers. Of header. Or connector is this one. So whenever you see, let me draw different headers or different connectors. So this is the connector of the 4 pins. You can also have another header of 8 pins. So 1, 2, 3, 4, 5, 6, 7, 8. So this is figure what? 25. The 4 pins connector. 4 pins connector. And this is figure 25B. There 8 pins connector. Filippo, you are Filippoing. Class, is it clear? So, I will show you the physical appearance of the headers and connectors. Then the schematic symbol of 40 of a microphone. Now let us go to the schematic symbol of a microphone. Schematic symbol 40 of microphone. Schematic symbol 40 of microphone or mic. So you know the function of the microphones is to convey the acoustic or the sound wave, the mechanical sound wave into electromagnetic wave. So the schematic symbol of a microphone is this. Is it? Huh? Is it a correct schematic symbol? No. How does it look like? Does it look like this? No. How does it look like? We have discussed this. Huh? Can you draw for your neighbor? We have discussed the schematic symbol 40 of the microphone. Because you have to differentiate the schematic symbol of microphone and buzzer. Try to draw it. So there is a different way that you can draw this schematic symbol of the microphone, but the common one is this one. Okay? Okay. There are the different ways of drawing the schematic symbol of the microphone. Because for instance, you can also draw another one, because I think that I've seen in one of the source. Or for instance, the other one can be like this. Yes. So either this one or this one, but here you have to draw. So this one, you can draw just a good what? A good diagram. So this is the point where it received the voice. For instance, this one. So this is the point where it received. And these are the two wires that are carrying electric signal. So this one, the main purpose, what does this represent? The main purpose is actually to provide the space to receive the mechanical signal, right? And then this is the representations of the either diaphragms, because we have different rates of the microphone. Then the mechanical signal is converted to electrical signal, and we provide this by using these two terminals. So figure 27A. So the schematic symbol of microphone. And this is figure 28 or 27B. Also the alternative or the schematic symbol of microphone. Okay, so I've forgotten the numberings, whether it's number what. I think that now if we remember the number of figures, 27, so maybe this is 28, something like that. So the schematic symbol of speaker, because you have to know these schematic symbols in order to draw the good quality schematic circuit diagram, right? Or whether if you cannot, because the purpose is for you to draw and analyze the different schematic circuit diagrams of the different size of the speaker. So the schematic symbol 40 of a speaker. So a speaker is a transducer. So what is speaker? Simply, when somebody asks you that simple question, what is speaker? So simple to answer this question. Speaker is a transducer that conveys electrical energy into what? Sound energy. This is the simple meaning of the speaker. So then the schematic symbol of the speaker is very interesting. So this we call it positive, because it depends which type of the speaker it is, and this is negative. So this is figure what? Figure 28B, the schematic symbol of a speaker. Then the next thing, electrical components, very important electrical components that you have to learn its schematic symbol is relays. I've talked about the schematic symbols of some mechanical switches, but also we have electromagnetic switches. So schematic symbol of a transformer. So before I teach you about relay, let me teach you about transformer. I know that you know the schematic symbol of the transformer, but just to remind you, this is the schematic symbol of the transformer, where we have a primary coil, and this is the iron core. Iron core. And then here we have a secondary coil. We have a secondary coil. So this is primary coil, and this is secondary coil. So this is figure what? Figure 29, the schematic symbol of a transformer. Then we need also to know, because you may need to use the schematic symbol. That's why I told you have to keep your SS book of electronics drawing. Schematic symbol of what? Of a motor. We use electric motors in most cases where we need motion, either translational motion, or rotational motion, or circular motion. We need what? Motors. So the schematic symbol of a motor, if you want to present a motor in a schematic circuit diagram, you have to know its schematic symbol. So this is what started. So the schematic symbol for a motor. So this is the way that we draw the schematic symbol of a motor. So a motor, it depends, because we have gear motor, we have DC motors, we have servo motors. So it depends. Some of the motors might have 3 terminals or 2 terminals, but most cases we use to present the symbol in this way. And here we used to have a capital M as the first letter of 40, a motor. Are we together? So M standing for 40 for motor. So this is positive terminal, this is negative. And this is commonly DC motors, because in electronics we use often DC motors rather than AC motors. If you want to use AC motors, then you need electromechanical switch. That's called the relays. Okay? So if you want to present a motor, this is the schematic symbol. Schematic symbol 40 of a motor. You can even reverse also. You can either draw in transverse or in, it means you can draw at the horizontal or at the vertical. So the other way that you can draw this, you can draw this symbol of motor. You should not claim that always should be horizontal. So this might be a positive terminal. And this one, it is a negative terminal. And here we have capital M. Then another electrical device is the schematic symbol of 40 of a fuse. This is very important electrical component. Hopefully, I assume that you know the meaning of the fuse and you know what does it do or what does it perform. So you should not worry about that. So simply say that the schematic symbol of a fuse is this one. So schematic symbol of a fuse so this is figure 31. 31. This is the schematic symbol so the main function of the fuse is to protect the other electrical part from the overcurrent. Schematic symbol of a fuse. Schematic symbol of 40 of a fuse. Again, let us learn the schematic symbols of 7 logic gates. So when we cover this concept, then it will be the end of workshop 3. So logical gates perform different function in electronic or in electronic devices. So we can say that in electronics and the telecommunication engineering, let us touch a little bit about digital, but in workshop 4 we learn a lot. There are 7 standard logic, there are 7 standard logic gates. Namely, number 1, we have what? AND gate. Possibly you know the schematic symbol of AND gate, but let me remind you. So the schematic symbol of AND gate, we use only 3 pins to represent the AND gates. So this is terminal 1, terminal 2. So this is input of the AND gate, and this is output. So this is terminal 1, this is terminal 2. Then the second one is NOT gate. So the schematic symbol of NOT gate is this. So this one is figure 32, the schematic symbol of AND gate. And this one is figure 33, the schematic symbol of NOT gate. Filippo is Filippo. Filippo is what class? Yes. Then number 3, we have also a logic gate that we call it OR gate. So it's a schematic symbol. It is one. So terminal 1, terminal 2. So this is in, this is out. So this here it is figure 34. The schematic symbol of OR gate. Schematic symbol 40, OR gate. Say OR gate. Then the fourth standard logic gate is called the NAND gate. Say NAND gate. So the schematic symbol of NAND gate is this one. Terminal 1, terminal 2, terminal 3. Figure 35, the schematic symbol of NAND gate. Then the fifth standard logic gate is called the NOR gate. NOR, say NOR gate. So the schematic You are welcome. So this is in, this is out. So this is terminal 1, terminal 2, terminal 3. Figure 36, the schematic symbol of NOR gate. These are the standard. We can have a NAND gate or the NOT gate of 3 terminals, more than 2 terminals. But this is the fundamental skills that you're trying to build in the mind of technicians, so in the minds of the beginner. Okay? So the concept of logic gates is broad more than you think, because it's a dominant of digital electronics. So the 6 standard logic gates is we call it's exclusive OR gate. This one in short we call it XOR. XOR. Say XOR gate. Say XOR gate. So this is the abbreviations, XOR gate. So the schematic symbol of XOR gate, it's simple, especially if you remember the schematic symbol of OR gate. So you see the difference. This is the difference between exclusive OR gate and OR gate. So here we have 2 lines, while here we have a single line. So you have to be careful. Okay? Yes. So this is terminal 1, terminal 2, terminal 3. So this is in and this is out. Figure 37, the schematic symbol of exclusive OR gate, XOR gate. Then the 7 standard logic gates is exclusive NOR gate or XNOR, the abbreviation, exclusive NOR gate. Say exclusive NOR gate. When you learn these individual logic gates as individual concepts, you might think that they are simple. Simple to identify, simple to remember, simple to understand. But I want to tell you that when you find all of these, I think 90% of the electronics and electrical components interconnected together in the complicated schematic circuit diagrams or in the intermediate schematic circuit diagrams, it will be difficult for you to identify each of the components. Right? Now just drawing this symbol as a separate or as an individual, it's not difficult. But when you find that the part of the circuit, it's difficult for you to remember all of this because these are the sum. Are we together? Are we together? So before you draw, you have to understand the philosophy behind and what does it represent. Okay? So the schematic symbol of exclusion, look, there's a relationship between OR gate and NOR gate. Okay? NOR gate is the combinations of OR gate and NOT gate. Are we together? What is OR gate? OR gate is the combinations of the 2 logic gates. NOR gate is the combinations of OR gate and NOT gate. So this symbol represents NOT gate. Okay? Sometimes also you can draw this symbol at this way. that this is OR gate connected with what? NOT gate. And remember that NOT gate, the symbol of NOT gate is not the same with the symbol of general purpose diode. The symbol of general purpose diode, or Schottky diode, or Zener diode, or light emitting diode, or photodiode, it has a line, not a small cycle. Right? You know that these concepts, if maybe you have gone through advanced physics, you might think that these are simple, I know them. But when it's come for the engineering concepts, and especially defining or interpreting the schematic circuit diagrams of other engineers or technicians, it's not simple the way you think. Are we together? Are we together? So this one is not, the NOT gate does not have any relationship with general purpose diode. Okay? Again, this we call the OR gate, as I said. When you combine OR gate with the NOT gate, we have NOR gate. And NOR gate, we call it a universal logic gates. Why? Because you can design all the other 6 logic gates by just using a NOR gate. That's another concept that you have to remember at the fundamental or at the beginner. Can I repeat? Can I repeat? Yes. NOR gate and the NAND gate. These in electronics we call them universal gates. Why do we call them universal gates? We can design AND gate by using NAND gate. We can design NOT gate by using NAND gate. We can design OR gate by using NAND gate. We can design NOR gate by using NAND gate. Okay? We can also design AND gate by using NOR gate. We can design NOT gate by using NOR gate. We can design OR gate by using NOR gate. We can design NAND gate by using NOR gate. I think that tonight we'll dream. You'll dream that, what you'll be hearing. You'll dream that sequence. NAND gate from design this one. So you are dreaming. Is this it? So we call NOR gate and NAND gates are what? Universal gates. Remember that the purpose of this workshop is not to teach about logic gates. It teaches about schematic symbols. But it's better for you to understand the concept. But again, remember that NAND gate, it's a combination of AND gate and the OR gate. AND gate and NOT gate. NAND gate is a combination of AND gate and NOT gate. NOT gate. And then NOR gate, it's a combination of OR gate and the NOT gate. Are we together? The word NOR, this is OR gate. And the N standing for NOT. The word NAND, N standing for NOT. N standing for AND gate. You will have a module known as digital electronics. I think that in your second year, we'll just learn this stuff in detail, okay? Should not worry, but I'm trying to introduce to you. So even this NAND gate, we can draw in this way, because NAND gate is AND gate plus what? NOT gate. So you can draw, Filippo, you can draw this one, means you can draw this schematic symbol in this way. So 1, 2, 3, so this is 1, so this is AND gate, NOT gate. Then this is the output. So the small cycle represents what? NOT gate. Okay? Exclusive OR gate, it's a combination of OR gate and something else. Exclusive NOR gate, now, so this, I made a mistake. This is exclusive OR, there's no small cycle here. Stop drawing, A. So exclusive what? Exclusive what? NOR gate. Exclusive NOR gate. So exclusive NOR gate, we draw, it's a combination of, so we draw like this. This exclusive NOR gate. Draw them carefully. And then, or exclusive NOR gate, we can draw it in by using this schematic symbol. So it's a exclusive NOR gate, the communication is a combination of what? Of exclusive OR gate and the NOT gate. So this is 1, 2, terminal 1, terminal 2. This is in, this is out. This is 1, this is 2, this is in, this is intermediate, this is out. So this is 1, 2, 3. Are we together, class? Okay, so if that's the case, the homework, let me give you the homework. So here it's a homework. Simple question. Draw the schematic symbol of integrated circuit, or IC, or with 4 to 16 pins at the home. So my dear students, this is the end of workshop 3. It has been interesting. I always end these workshops at the end with something new in your mind. But remember, the focus of the modules is drawing. It's not about the operations so forth of the electronics component. So this is the end. In case you have any question, don't hesitate to ask it. But I would like to invite you in the workshop number 4. When we'll do corrections of this homework, we'll be dealing about the schematic symbol of integrated circuits and also some other electronics components. So stay tuned and see you in the next class.